Physical Science. This is Mr. B, and we're going to start our last section today, and it's going to talk about how we as humans utilize heat. And there's a couple main ways that we utilize heat, and the first one that we're going to focus on are engines is what's going to focus on today. So many gearheads out there who really like cars, you might have a little bit of an advantage over some of the other people, because our first section here in section 3 is going to talk a lot about different types of engines that we have. So again, to start, we always have our example. So heat engines, which we introduced into our last section, they played a key role in the development of the modern industrial world. An example is a steam locomotive. They were an important early use of the steam engine, and electric power plants today use what are called steam turbines. So the steam engine, again, powered our early trains, and again, there's still some of the same concepts are still in use when we use steam turbines in a lot of our electric power plants. And so to start, now we're going to actually look at the two main types of heat engines that we actually have. So we have what are called external combustion engines and internal combustion engines. So those are our two types that we are going to focus on in this video, the difference between an external combustion engine and an internal combustion engine. So our example that we just looked at right there is a steam engine. It is an engine that is an external combustion engine. External combustion engine, and that's a mouthful, and it burns fuel outside of the engine. So the fuel is actually burned outside of the thing that it's actually powering. So it's burned outside of the engine. So there's a guy by the name of Thomas Newcomen. Newcomen is how he pronounces his name. He developed our first practical steam engine in 1712 to pump water out of a coal mine. So that was our first real use of the external combustion engine. Then a guy by the name of James Watt, and we've talked about him before, he designed an engine in 1765 that operated at a higher temperature and therefore was much more efficient than the steam engine that was originally designed up here. So we've talked about Watt before, and again, you're going to answer some questions that kind of focus more on the use or kind of what these two guys did. And so here's the basic picture of how a steam engine works. And in class, I'm going to have you take a look at this more in depth, so don't worry about writing down any of these parts or anything, because you're going to have to do it in class. So when the valve, so how a steam engine basically works is that the valve in a steam engine slides, and then steam is trapped inside of a cylinder. So here's our cylinder right here, and you notice this sliding valve is right here, so it moves and it brings the hot steam in. Again, it gets trapped down into here into the cylinder, and then as the steam expands and cools, it pushes the piston to the left. So you can follow right here. So the hot air comes in, again, because the fuel is burnt outside because it's an external combustion engine. And so as the fuel is burned, steam comes in. So steam comes in, red, red, red. Steam goes through because originally this valve is all the way over here. So it's letting the steam come in. It lets the steam come in. And then the valve slides over and traps the heat in here, or traps the steam in here. So then the steam expands and it pushes this piston over and over and over, and then the cool air or the exhaust steam, and once it turns blue, that means it's now leaving the system. And so this pushing motion right here, this piston pushing the cylinder, that's where our work is being done. So you're going to have to do, again, more with this in class, but that's basically how it works. So the steam comes in because, again, it's an external combustion engine. Again, the heat falls here, gets trapped down in this cylinder, and the valve kind of keeps it there, and then it pushes and it expands and it expands, and that is what's going to drive the engine to work. So that is how an external combustion engine works. And then an internal combustion engine is a heat engine in which the fuel burns inside the engine. So it's not going to be outside, it's now burned inside the engine. So most internal combustion engines use pistons that move up and down inside cylinders, and each upward or downward motion of the piston is called a stroke. So if you've heard of like a 4-stroke engine or something like that, if you're, again, I'm not really huge into cars or trucks or anything like that, but that might mean more to you if you are in fact more mechanically inclined. And so here is again kind of a picture how the heat engines work. So most cars have what's called a 4-stroke internal combustion engine, and on this diagram shows only one of the cylinders during each stroke. So again, as this piston moves up and down, again, it's called the 4-stroke engine because it has probably multiple pistons, but this is just one of the cylinders during each of the strokes. Again, it's constantly moving up and down, up and down, up and down. And again, your book has a really good description of what causes again, each one of these motions to occur. So we're going to kind of wait to do that in class and take a little bit more, because this one's a little more complex than the internal or the external combustion engine. So in the internal combustion engine, the cooling system and exhaust transfer heat from the engine to the environment. So that's why you have the exhaust at the back of your cars. Again, it's because it's the excess heat that is produced. Again, we can't keep it inside the engine because that's going to kind of reduce our efficiency. So we got to kind of move it away. And so gasoline engines that we have now inside of our cars, they are more efficient than our old-fashioned steam engines. However, they're still not they're not considered to be overly efficient, or kind of our best case scenario, because about 1/3 of the energy in the gasoline engine is converted to work. That means 2/3 of the energy that is stored in the gasoline is just used for nothing. So only 1/3 of the energy that we could be harnessing from gasoline is actually being converted into work. So that's kind of, again, kind of shows why we might need to maybe try to find a better new design. Again, it's kind of hard to find something that's as practical as what we have now, but again, it's going to be a big source for the future, because like we talked about in our last chapter, our fossil fuels are limited resources, and all this stuff kind of ties in together with and this stuff not being the most overly efficient thing that we have. So we're going to go ahead and stop there, and we're going to talk about another way that we use heat in our next video, and our last one for this chapter. So let me know if you have any questions.